Hello dear aspirants, welcome to Epitome IAS. So we are doing this PYQ analysis of UPSC Prelims. So today's topic is Physical Geography. So the first question is, consider the following: pyroclastic debris, ash and dust, nitrogen compounds, sulfur compounds. How many of the above are products of volcanic eruptions? So if you see, this question was asked in 2024. So if you see the volcanic eruption, it has a variety of things coming out of it. Okay. So if you see the pyroclastic debris, yes, this is part of the volcanic eruption, and it also contains ash and dust. Apart from that, it also contains some of the gases. So the nitrogen compounds and nitrogen gases, sulfur compounds and sulfur gases are also part of the volcanic eruption. So the correct answer would be all four. Option D is the correct answer. So the second question, consider the following statements. Statement 1, rainfall is one of the reasons for the weathering of rocks. Statement 2, rainwater contains carbon dioxide in solution. Statement 3, rainwater contains atmospheric oxygen. So which of the following is correct? Option A, both statement 2 and statement 3 are correct. Both of them explain statement 1. Option B, both statement 2 and statement 3 are correct, but only one of them explains statement 1. Option C, only one of the statements of 2 or 3 is correct, and that explains statement 1. Option D, neither statement 2 nor statement 3 is correct. So if you see the rainfall, it also causes some of the weathering. We can say the chemical weathering of rocks. So the first statement, rainfall is one of the reasons for weathering of rocks. Yes, this statement is correct. If you see the statement 2, rainwater contains carbon dioxide in solution. Yes, this is also correct. Rainwater contains some carbon dioxide in it, and it actually causes the weathering of rocks. And if you see statement 3, rainwater contains atmospheric oxygen. Again, this statement is also correct. The rainwater also contains the atmospheric oxygen. And if you see both this carbon dioxide and the atmospheric oxygen, these both are the reasons for weathering of rocks. So the correct answer would be both statement 2 and statement 3 are correct, and both of them explain statement 1. So the correct answer is option A. So if you see, the next question is, on June 21 every year, which of the following latitude experiences a sunlight of more than 12 hours? More than 12 hours. So first statement, equator. Second, Tropic of Cancer. Third, Tropic of Capricorn. And fourth, Arctic Circle. So they are asking on June 21, which of this particular latitude or latitudes they have the sunlight of more than 12 hours. So if you see, this is a, so if you see there is a basic fact that, let's say, this is the earth and this is the sun. So what happens on June 21 is the sun rays, the direct sun rays, it falls on the Tropic of Cancer. Let's say this is Tropic of Cancer, and this is equator, and this is Tropic of Capricorn. So if you see the direct sun rays, it falls on the Tropic of Cancer, and if you see clearly the sun rays, the total sun rays, it will be lying there between the North Pole and till the Tropic of Capricorn, and this particular South Pole, it will be not having any sort of sun rays. The South Pole, especially after the Tropic of Capricorn till the South Pole, it is complete darkness, right? So they are asking that on June 21, which of the following latitudes will be having sunlight of more than 12 hours? So clearly if you see, the Tropic of Cancer is going to have the sunlight of more than 12 hours. And if you see the Arctic Circle, it is somewhere near here. The Arctic Circle, it will be having the sunlight of more than 12 hours definitely. Why? Because this particular North Pole is going to have the daylight of 6 months. Simultaneously in the South Pole, it will be having the night of 6 months, and here there is no sunlight for 6 months. So what is the correct answer? The correct answer is Tropic of Cancer. Yes, it is having more than 12 hours of sunlight, and Arctic Circle, because it is also going to have sunlight of more than 12 hours. To be precise, for 6 months, it will be only days, no night. So the correct answer would be option D, 2 and 4. So the next question. Illuminate and rutile abundantly available in certain coastal tracts of India are rich sources of which one of the following? This question was asked in 2023. Option A, aluminium. Option B, copper. Option C, iron. Option D, titanium. This is a factual question. The correct answer would be titanium. This illuminate and rutile, these are some of the minerals which are abundantly found in titanium. And this particular titanium is available throughout the coast of India, starting from the Gujarat till the West Bengal. Throughout the coast of India, we are having this titanium. But there are certain spots, there are certain places where we have this metal in an abundantly. So what are these? Let us see in detail. So if you see here, illuminate and rutile are the two chief minerals of titanium. Illuminate and rutile, along with other heavy minerals, are important constituents of beach sand deposits. So these are found in the beaches. So if you see throughout the coastal area of India, we find this particular deposits. But especially there are 5 well-defined zones where this deposits can be seen in much quantity, quality. What are they? The Chavara deposit, that is in Kerala. Let's say this is the coast of India, and in Kerala we have this Chavara deposit, and we have MK deposit in Tamil Nadu and Chhatrapur coast. It is also called as Oscom deposit. This is in Odisha. And there is another Brahmagiri deposit. This is also in Odisha. And the 5th one is Bhavanapadu coast, that is in Andhra Pradesh. So these are some of the major well-defined zones of this particular deposits, and we have these 5 deposits here. So let us go to the next question. Consider the following statements. Statement 1, in a seismograph, P waves recorded earlier than S waves. Statement 2, in P waves, the individual particles vibrate to and fro in the direction of the wave propagation, whereas in S waves, the particles vibrate up and down at right angles to the direction of the wave propagation. So first of all, we have to understand what are these P waves, what are these S waves, and what are their important characteristics. So if we talk about the earthquake, we will be talking about the earthquake. There are certain waves which are related to earthquake. Let us say this is the surface. This particular line is the surface of Earth's surface. And let us say there is some point. This is a point. This point is inside Earth's surface. Okay. So let's say there is a rupture in a rock, and a particular earthquake is starting from this particular point, then what happens? First, this waves will be traveling in all directions like this. In every direction it will be traveling. These are the earthquake waves. So what happens is, these waves which are traveling inside the earth, these are called as body waves, because they are traveling inside the body of the earth. And if you see the body waves, it is of two types. What are they? One is primary waves and the other one is secondary waves. The primary waves we call it as P waves and the secondary waves we call it as S waves. So body waves, it is of two types. And if you see here, this particular point where the earthquake is started, where the rupture of rock is happened, this point is called as focus. And this body wave, it reaches the surface of the earth. Let's say it's reaching the surface of the earth in all the directions. But the shortest distance between the surface of the earth and the focus, this is what is calculated. So this particular point is called as epicenter. So the shortest distance from the focus to the surface of the earth. So this particular point will be the epicenter of this particular earthquake. Then what happens after reaching this particular epicenter? Another sort of waves are formed. And these waves are called as surface waves. So if you see here, the question is about the P waves and the S waves. So in detail, if you see these P waves, they travel much faster than the secondary waves, because they are called as primary waves, right? Because they pass much more faster than the secondary waves, and secondary waves will be somewhat slower than the primary waves. So let us say from the focus, the waves which travel faster and reach the surface of the earth, these are the primary waves, and those waves which are much slower and reach the surface somewhat slowly, these are the surface waves. These are the secondary waves. So the first statement says, in seismograph, the P waves are recorded earlier than S waves. Yes, the P waves are recorded earlier than the S waves. Why? Because the P waves, they travel faster than the S waves. And seismograph is nothing but it records these waves, these earthquake waves. So this particular statement is correct. And if you see the second statement, it is saying that the P waves, it actually vibrate to and fro in the direction of wave propagation. Yes, this is true. The P wave, how it travels, let's say this P waves are traveling in this direction. So what happens is, it vibrates to and fro like this. So what happens? These P waves vibrate to and fro in the direction of the wave itself. The waves are going in this direction and it is vibrating to and fro in that particular same direction. So this part of the statement is correct. And the second part, what they are saying is, S waves. In S waves, the particles vibrate up and down at the right angles. So let's say this is the direction of the S wave. It is going in the upward direction. So what will happen is, in the S waves, the propagation will be happening perpendicular to the direction of the waves. So it will be at the right angle to the direction of the wave. Let's say the direction of the wave is towards upwards. So the propagation will be happening on right angles both the sides. So this particular statement is also correct. So what is the correct answer? Option C, both 1 and 2 are the correct statements. If you see here, yes, there is this earthquake waves and there are two sort of earthquake waves. What are they? One is body wave and another one is surface waves. And as I already told you, the body waves are the waves which are traveling inside the body of the earth. And the surface waves are the waves which are traveling on the surface of the earth. Simple. There are two types of body waves. Again, In the body waves, we have two types, that is P waves and the S waves. P waves is nothing but the primary waves and S waves is nothing but the secondary waves. So, here we have the difference, basic difference between the P waves and the S waves. So, first point is P waves are the first to arrive at the surface. And if you see the surface waves, they take some time to reach the surface. There is a time lag in the S waves. And the second point is the P waves vibrate parallel to the direction of the propagation of wave. Let's say this is the direction of the wave. It will vibrate to and fro in the same direction. It is parallel to the direction of the wave. But in case of the secondary waves, it vibrates perpendicular to the direction of the propagation of wave. Again, let's say this is the direction of the secondary wave. It will be vibrating in the perpendicular direction to the direction of the waves. And if you see the next point is, these P waves are less destructive. They are not much destructive. Why? Because it is propagating in the direction of the wave. It is moving like this, back and forth like this. So it will not create much destruction. But if you see the secondary waves, they create much destruction. Why? Because let's say there is a rock and this particular secondary wave is passing through this rock. So the force is applied perpendicular to the direction of the wave. So this particular rock will be disturbed, right? So the destruction is more in case of secondary waves compared to the primary waves. The next point is, these can travel through all mediums. This is one of the important points. The P waves, it can travel through the solid, it can travel through the liquid, and it can also travel through gas. But in case of secondary waves, it can travel only through the solids. It cannot travel through liquid or gas. So how this point is important? We all know the interior of the earth. So let's say this is the crust, this outer layer, and this is the mantle, the inner layer, and this is mantle, and we have the core. And we also know that, let's say this is the outer core, and this is inner core, and this is mantle. So we all know that mantle is somewhat solid. And if you see the outer core is a liquid, and the inner core, again, it is solid. So what happens? These primary waves, it will help us understand the interior of the earth. Let's say this primary waves are traveling from here. So definitely these can travel through the solid. It can travel through the liquid and again through the solid. So the secondary waves, what will happen? They only can travel through the solid, and again this is a liquid layer. So the secondary waves, they cannot travel through the liquid. So what will happen? They will change the direction and they will move on this direction. So it will help to figure out the interior of the earth by the scientists. Okay, that's why this point is important. The P waves and the S waves help in understanding the interior of earth. And this point, the P waves can travel through every medium, solid, liquid and gas, but the S waves can only travel through solids. They can't travel through liquid or gas. So this point is important. Then these P waves are compressional waves. And if you see these S waves, they causes displacement of rocks and collapse of structure, as we already saw this. So let us go to the, yes, this is what I was talking about. Let's say this is the shadow of the, P wave, then it will actually travel through the solid and it can also travel to the liquid. But in case of S wave, it can only travel in the solid. It can't travel to the liquid. So these are the pictures of the shadow zone. So these are the shadow zone of the S wave, and if you see here, this is the shadow zone of the P wave. So the next question. In the northern hemisphere, the longest day of the year normally occurs in option A, first half of the month of June, option B, second half of the month of June, option C, first half of the month of July, option D, second half of the month of July. So in the northern hemisphere, the longest day of the year normally occurs in, just now we saw this June 21, sometimes June 22 also, sometimes, but mostly June 21, this day is called as summer solstice. Summer solstice. Why? Because the direct sun rays falls on the Tropic of Cancer. What it means? The northern hemisphere, it is having the longest day on June 21. So what would be the correct answer? If you see option B, second half of the month of June. June 21 is in the second half of the month of June. So the correct answer would be option B. If you see here, we have a clear picture of what happens. Let's say this is sun, this is earth, it is tilted. And as you can see on June 21, the summer solstice, it happens. The direct sun rays, it falls on the Tropic of Cancer. So the northern hemisphere, it has summer, and the southern hemisphere, it will be having the winter. So this particular day, the northern hemisphere will be experiencing the longest day. And if you see on December 22, the exactly opposite thing is happening. What is happening here? The direct sun rays, it falls on the Tropic of Capricorn. So what will happen? The southern hemisphere, it will be experiencing summer, and the northern hemisphere, it will be experiencing the winter. So this part during the winter solstice, in the northern hemisphere, we will be having the shortest day. And if you see, there is another two cases. We call them as equinox. What is this equinox? Equinox is nothing but we have the day and the night equal. In summer solstice, we have bigger day, longer day. In winter solstice, we have longer night, shorter day. But in equinox, we have equal day and night. So we have two equinoxes. One is spring equinox and the other one is autumn equinox. So the spring equinox, it happens in 21st March. So what happens is the direct sun rays, it falls on the equator. The direct sun rays falls on the equator. So the both northern hemisphere and the southern hemisphere have equal distribution of sunlight. So here the day and night are equal both in northern hemisphere and in the southern hemisphere. The same thing happens in autumn equinox. It happens in 23rd September. So what happens? Both northern hemisphere and southern hemisphere, we have equal day and night because the direct sun ray falls on the equator. Again, it falls on equator. So the next question. On 21st June, the sun. See, again we are talking about this particular date. 21st June, it is summer solstice as we already saw. What are the options they are giving? Option A, does not set below the horizon at the Arctic Circle. They are saying the sun will not set below the horizon at the Arctic Circle. Option B, does not set below the horizon at the Antarctic Circle. Option C, shines vertically overhead at noon on the equator. And option D, shines vertically overhead at the Tropic of Cancer. So if you see the answer, what is the answer? Already we saw on June 1st, 21st, what happened? Let's say this is Earth and this is Sun. So the direct sun rays, it falls on Tropic of Cancer. This is equator, and let's say this is Tropic of Capricorn. So what happens is, option A, they are saying in Arctic Circle there is no sunset. Is that true? Yes, on June 21, this whole north hemisphere, it is having the sunlight, and especially this Arctic Circle and the North Pole, it is having complete sunlight for around 6 months. It is not at all having a single night. So they are saying the sun will not set below the horizon. So this statement is correct. Yes, in the Arctic Circle, there is no sunset because it is complete day. There is no night. If you see option B, it does not set below the horizon at the Antarctic Circle. If you see around the Antarctic Circle, what will happen? It is complete night. The sun is already set there for 6 months. So this option is wrong. If you see option C, it shines vertically overhead at the noon on the equator. Last PDF we saw this, last page. Here we saw this. Only there are 2 occasions where the sun is directly overhead in the equator. What are these? A spring equinox and an autumn equinox. Only these 2 times the sun directly, it has the direct rays over the equator. So we can say if we are standing in the equator, the sun is overhead. Okay, apart from these 2, one is spring equinox, the other is autumn equinox. Apart from these 2 cases, the sun is not overhead at all. If you see in the summer solstice, we have sun overhead on the Tropic of Cancer, and in winter we have sun overhead on the Tropic of Capricorn. But what they are saying, the sun shines vertically overhead at the noon on the equator. No, this won't happen. It will happen in either spring equinox or autumn equinox, not on the summer solstice. Then if you see option D, shines vertically overhead at the Tropic of Cancer. You tell me, what is this? When the sun is vertically overhead in the Tropic of Cancer, it is nothing but the winter solstice. So again, this is not summer solstice, this is summer solstice. So this particular option is also wrong. So the correct answer is option A. So the next question, the word Denisovan is sometimes mentioned in media in reference to A, fossil of kind of dinosaurs, B, an early human species, C, a cave system found in Northeast India, D, a geological period in the history of Indian subcontinent. So if you see this Denisovan is directly related to early human species. So the correct answer would be option B. It is an early human species. So if you see here, the Denisovans are an extinct group. They are already extinct of humans that lived across Asia during the lower and middle Paleolithic periods. They are known primarily through DNA evidence, as physical remains are scarce. The first Denisovan individual was identified in 2010 from a finger bone found in Denisova cave in Siberia. So the next question, which of the following, these are possible consequences of heavy sand mining in riverbed? 1, decreased salinity in the water. 2, pollution of groundwater. 3, lowering of water table. So they are asking about what are the possible consequences when we are doing heavy sand mining. This happens usually in the riverbed, right? Heavy sand mining. So what are these consequences? So first, they have given the decreased salinity in the water. Second, pollution of groundwater. Third, lowering of water table. So if you see this, yes, lowering of water table, it is there. Why? Let's say these are the sand which are there in the riverbed. So these sand aquifers, it help in absorption of the water. So what will happen? The groundwater table, it will help in the maintenance of the water level in the groundwater table. So here what they are saying, it actually leads to lowering of water table. This table, yes. Why? Because when you are removing this sand, then what will happen? Its purpose is gone. It's not there. So it is actually helping in the refill of the maintaining of the groundwater. So this is not happening when you remove the sand from the river. So yes, it will lead to lowering of water table. And second is pollution of groundwater. How? Again, let's say there is some mine activity which is happening nearby, or let's say there is a sea nearby. Now when you are removing the sand from the river bed, what will happen? This acts as a barrier, right, to the groundwater. Now these particular pollution or this water, sea water, ocean water, it comes in and it mixes with the groundwater. So what will happen? This groundwater is contaminated. So yes, it will also lead to the pollution of groundwater. And the third point, first point is decreased salinity in water. Is that so? When this sand is removed, what is happening? This pollution or this sea water is coming inside and it is mixing with the water. So it will actually increase the salinity. Increase the salinity of the water. It will not decrease the salinity of the water. So we can eliminate this particular option. So what is the correct answer? Answer is B, 2 and 3 only. So if you see here, these are the impact of the sand mining. What are the impact? First of all, the excessive sand mining can alter the river bed and force the river to change its course. And it will also lead to erode of banks and it will cause flooding. This is the first impact. Then the second point is it causes river and estuary deepening as well as the expansion of the river mouth and the coastal inlets. Let's say this is the river. So now what happened when you are removing sand from it again and again? It widens, the mouth of the river widens, and let's say there is a nearby sea which is there to this river. This water, sea water, it comes in and it will occupy this particular area. So what will happen? It will increase the salinity of this water. So it may result in saline water intrusion from the nearby sea. Next point is this sand aquifers help in recharging the water table. As I already explained you, this sand aquifers, it will help in recharging the water table and maintain the water table underground. But now what's happening? This progressive depletion in the river is accompanied by lowering of water table in the nearby area. And next point is as the turbidity increases at the mining site, saline water intrusion takes place along the coastal aquifers, thereby polluting the groundwater. We already explained this particular point. So the next question, which of the following phenomena might have influenced the evolution of organisms? 1. Continental drift. 2. Glacial cycle. So if you see, they are asking which of these two phenomena have influenced the evolution of organisms. So this is kind of a very broad sense they are asking. So let us say first they have given the continental drift. So what happens during the continental drift? We read this. The continents, initially they were together, then they broke up and these continents move apart, right? So what happens is, let's say there are some species, animal species or any organisms living in this particular plate and it is moving, this plate is moving and it is going and joining with some other plates. For example, we have this Indian subcontinent. Initially it was part of some other plate and it broke and it traveled north and it collided with the Eurasian plate. So when it collided with the Eurasian plate, this Himalaya, it was formed. So we know this. Let us say when this particular plate or continent was drifting from some other plate, some of the species which are living inside this particular continent, it will also be moving and it will be joining in some other continent. So this will also lead to the evolution of some organism. Some organism living in some other place, it is going and evolving in some other place. Yes, so this is also a possibility that continental drift will influence the evolution of organisms. Then second is glacial cycles. So what happens in glacial cycles? There are times where it is extremely cold, where during this ice age, so what happens is some of the species, they became extinct during those periods. And let's say sometimes, like during these times, we have global warming and these glacial ices, they melt and they mix with the sea water, and it will also lead to the increase in the level of the sea. So what happens again, some of the species, they might go extinct because of this also, or it will influence the evolution of organisms in both the ways, during the extreme ice age also or during the melting of ices also. So in both ways, these glacial cycles, they are also influencing the evolution of organisms. So both continental drift and glacial cycles, they influence the evolution of organisms. So the correct answer is C, both 1 and 2. So the next question, variations in the length of daytime and nighttime from the season to season are due to. Option A, the Earth's rotation on its own axis. Option B, the Earth's revolution around the Sun in an elliptical manner. Option C, latitudinal position of the place. Option D, revolution of the Earth on a tilted axis. So if you see, they are not asking about what is the cause of day and night. They are asking about what is the cause of variation in the length of the day and night. Sometimes we have a long day and a short night. Sometimes we have a long night and a short day. Especially during winter, you will be having a long night. During summer, we will be having a long day. So they are asking what is the reason for this particular variation in the length of day and night. So it is very simple. It is based on the seasons. Let's say the Earth is tilted, we know this, and there is a revolution. This is the Sun, it is revolving around the Sun. So this particular revolution along with the tilted axis, these both cause the variation in the length of day and night. We already saw this during the summer solstice, the direct sun rays, it falls on the Tropic of Cancer, and the whole northern hemisphere, it will be having a longer day, and in southern hemisphere simultaneously we will be having shorter day. But during the winter solstice, what will happen? We'll be having longer night. In southern hemisphere, they'll be having longer day. So what is the basis for this? The revolution of Earth and a tilted axis. Both these are the reasons for the variation in the length of daytime and the nighttime. And if you see option A, it is talking about Earth rotation on its axis. Let's say Earth is rotating. It's not revolving, but rotating. What will happen? Yes, there is a difference. It forms day and night. The side which is in front side of the sun, it will be having day. The opposite side, it will be having night. But there is no variation in the day and night. There is both the night and the day, they will be equal. So this option is wrong. And second, they are talking about Earth's revolution around the sun in an elliptical manner. Let's say there is no tilt, but the Earth is just revolving around the sun. Then obviously we won't be having this particular seasons, right? Both the northern hemisphere and the southern hemisphere, they'll be having equal day and night. It will be similar to the equinox, right? So this particular option is also wrong. The revolution along with the tilted axis, it causes for the variation in day and night. and latitudinal position of a place. Let's say there is no revolution, there is no rotation, but latitudinal position, it doesn't mean anything. So this also is wrong. So the next question, on the planet Earth, most of the fresh water exists as ice caps and glaciers. Out of the remaining fresh water, the largest proportion is found in atmosphere as a moisture and clouds. Option B is found in freshwater lakes and rivers. Option C exists as groundwater. Option D exists as soil moisture. So we already know we are the blue planet, right? So nearly 71% of the earth is covered with water, and this total water, in that total water, around 97% of the water is saline water. Only 3% of this water is fresh water. So they are asking that out of this fresh water, these 3%, the majority are ice caps and glaciers. So what is the second largest component of this particular fresh water? So if you see here, they have clearly given what is the percentage. Obviously, we know that the ocean, they contain about 97% of the water, that is the saline water. But apart from that, the other 3% of the water is the fresh water. So the ice caps and the glacier, they contain around 2.05% of water. So this is the largest component of the fresh water. So the second largest is the groundwater, which contains 0.68% of the waters. So the second part is, that is the second component is groundwater. So the correct answer would be the groundwater. And the next, that is the lakes and soil moisture, the atmosphere, streams and river, biosphere. So you have to at least remember the order, at least the order of the amount of fresh water. So what is the correct answer? The answer is groundwater. That is option C. So the next question, consider the following: electromagnetic radiation, geothermal energy, gravitational force, plate movements, rotation of Earth, revolution of Earth. So which of the following, which of the above are responsible for bringing dynamic changes on the surface of Earth? They are simply asking which of these can make any change to the surface of Earth. So if you see the electromagnetic radiation, let us have a detailed discussion here. If you see here, the electromagnetic radiation, it causes temperature change and evaporation of water. It will result in, again, if water evaporation is happening, it will result in precipitation. Rain will be coming. Then formation of metamorphic rocks. So these are the process which happens due to electromagnetic radiation. So yes, electromagnetic radiation, it is causing some sort of influence in the surface of the Earth. And if you see, the energy which is emanating from within the Earth's interior is the main force behind the endogenic geomorphic processes. Again, these geomorphic processes which are because of the interior of Earth, these are responsible for some of the changes in the lithosphere. So again, the geomorphic processes are also included. Then, due to the variation in the geothermal gradient and heat flow from within, the crust thickness and strength, the action of endogenic forces are not uniform and hence tectonically controlled. Original crustal surface is uneven. So if you see, let's say this is the crust, it is not even, the size of the crust is not even. Sometimes it is thicker, some places it is thinner, and again, some places it is thicker. So this is because of the geothermal gradients which are happening inside the interior of Earth. So this geomorphic processes, this is also one of the important factors which is impacting the surface of the Earth. And if you see the third point, gravity, besides being a directional force, activating all downslope of movement, it also causes stress on the Earth's material. Let's say we have a mountain. This is a slope which we have, and there are some rocks here. So this gravity, it acts on this force, this rock, and it will cause mass movements, and this will impact the surface of Earth. So again, gravity is one of the factors which are influencing the surface of Earth. Then again, plate tectonics, plate movement results in continent building and earthquake. We already saw when the plates are moving, what will happen? Let's say when two plates are colliding with each other, we usually read some sort of fold mountain will be forming, right? So this plate movement, it will be helping in the continent building, and sometimes this particular boundary, it will be having earthquakes. So again, the surface of the Earth, it has an influence due to the plate movement. So again, this point is also there. Then rotation of Earth about the axis results in the uneven heating of the Earth surface, which causes pressure difference and forms the winds. And these winds are associated with the phenomenon like rainfall, heat budget, and ocean currents, etc. So again, rotation of Earth is also responsible for the changes in the surface of the Earth. And again, apart from the rotation, the revolution of the Earth, it will also cause the differences, as we already read about this aphelion and the perihelion, that is the shortest distance between the Earth and the Sun and the longest distance between the Earth and the Sun. These also create the intensity of the sunlight which reaches Earth. Let's say when the Earth and the Sun are very close to each other, then the direct sunlight which the Earth receives will be maximum. Let's say the Earth is somewhat farther to the Sun, then the sunlight which Earth receives is somewhat lesser compared to the previous case. So this will also cause some sort of, changes in the Earth's surface. So let us go back to the question. So electromagnetic radiation, yes, it is there. It is causing some sort of changes in the surface. Geothermal energy, yes. Gravitational force, yes. Plate movement, yes. Rotation, revolution. So all these factors cause some sort of changes to the surface of the Earth. So what is the correct answer? Option D, 1, 2, 3, 4, 5, 6. So the next question, contour bunding is a method of soil conservation used in option A, desert margins liable to strong wind action. Option B, low flat plains close to stream courses liable to flooding. Option C, scrublands liable to spread of weed growth. Option D, none of the above. If you see this contour bunding, it will be like something like this. I'll show you picture so you will be understanding. So this is the picture of the contour bunding. So it will be like this, some sort of contour. So what is this contour bunding? It is a method of soil and water conservation in hilly areas. The earthen embankments are built across the slope of the land following the contour as close as possible. This helps in reducing the flow of water down the slope. Let's say this is a slope. We have the mountain, and the water flow or the soil erosion happens very easily because of we have gravity and this is a slope. So what they do is they do some sort of contour bunding like this, so that it will preserve the soil and it will help reduce the soil erosion. And if you are putting water also, it will help reduce the flow of water. Otherwise, what will happen? The water will flow very fast due to gravity. So this is contour bunding. So if you see here, the option is desert margins. No, it is not at all related to deserts. Low flat plains. No, it is not related to plains. It is related to mountains. It is because of the slopes which we are building this contour bunding, right? Then scrublands liable to spread of weed growth. No, it's not related to this also. So the answer would be D, none of the above. It is actually related to the slope, the mountains. So, which one of the following sets of elements was primarily responsible for the origin of life on Earth? Option A, hydrogen, oxygen, sodium. Option B, carbon, hydrogen, nitrogen. Option C, oxygen, calcium, phosphorus. Option D, carbon, hydrogen and potassium. So the correct answer is carbon, hydrogen and nitrogen. If you see, these three are the basic, elements which are responsible for living of any organism. So these are the, so see here, the carbon and hydrogen became hydrocarbons and hydrocarbon chains in the cell membranes and are essential component of life. So carbon and hydrogen are important for the survival of organisms. Then these five elements, carbon, hydrogen, oxygen, nitrogen and sulfur. Sulfur forms amino acids of protein, and if we exchange phosphorus for sulfur, 5 elements also compose nucleic acids like DNA. So these 5 elements, carbon, hydrogen, oxygen, nitrogen and sulfur, are very important for survival of any organism. So the next question, a person stand alone in a desert on a dark night and wanted to reach his village, which was situated 5 kilometers east of the point where he was standing. He had no instruments to find the direction, but he located the pole star. The most convenient way now to reach his village is to walk in the direction. Which direction? Option A, direction facing the pole star. Option B, direction opposite to the pole star. Option C, direction keeping the pole star to his left. Option D, direction keeping the pole star to his right. So we also know this, that the pole star, it is in the north direction. From the northern hemisphere, they can spot the pole star, and in the southern hemisphere they can't see the pole star because it is directly in the axis of the earth in the north direction. So let's say I am standing here and this is my north and I am facing the pole star. Now what they are saying is his village is situated in 5 kilometers east. So this is north. What will be the east? Let's say this is north, this is west, this is east, and this is what? This is south. So if you see here, I am facing north, so I should be moving towards my left. So if I move towards my left, I will be reaching my, my village after 5 kilometers. So the correct answer would be direction keeping the poles at his left. We should be moving towards the left while facing the north, that pole star. So this is the correct answer. The correct answer is C. So the next question, with reference to the soil conservation, consider the following practices: crop rotation, sand fences, terracing, wind breaks. So which of the following are related to the conservation of soil? So if you see crop rotation, what is crop rotation? Let's say during different seasons, they are cultivating different crops. Let's say I am cultivating some sort of crop for 3 months, and once that is over, I am removing them and I am putting some other type of a crop in that particular land. So this particular crop rotation practice, it will help in the soil conservation. How? Let us say I am using some different types of crops throughout the year. I am not using the same type of crop again and again. So what will happen? The different type of nutrients, it will be consumed by the plant, and the other type which are deficient in the soil, it has some time to revive those nutrients. If I am cultivating the same crops again and again and again, those particular crops, they need some sort of nutrients. Those same nutrients are again consumed again and again. After a point, this soil will be deficient of that particular nutrient. So this crop rotation will actually help in the preservation of the soil. Then what is sand fences? let's say in the desert areas, we have this sand dunes. The sand will be carried away by the winds. So these sand fences, let's say these are some of the fences which are placed. So what will happen? These sand fences will be preventing the wind to take away these sands. It will act as a barrier, and it will stop the winds, and it will stop the sand from carried away to another area. So yes, sand fences, it will also help in the conservation of soil. Then terracing. Just we already saw the contour bunding. It is similar to the terracing. Let's say there is a mountain, and in this slope they want to cultivate some sort of a crop. So in terracing, what will happen? They will be cultivating it in sort of a terrace. So again, this will help in soil erosion, because in the slope, it is prone to soil erosion. And if you are putting water, it is prone to flow very fast. So when you are doing this terracing, it will also preserve the soil from the soil erosion, and the water is also properly regulated. So yes, terracing is there. Then wind breaks. Let's say there is some sort of, so let's say there are some crops in this particular area. Now these winds are blowing very fast, and it is impacting the growth of the crop. Now what we will do? We will plant some of the trees here. So when we are planting some layers of trees in this particular direction, perpendicular to the direction of the winds, what will happen? This wind, it will stop here, and this will act as a barrier to stop this wind, and it will not impact the crops. So these are wind breaks. Yes, these wind breaks are also helping in the conservation of soil. So what is the correct answer? Answer D, 1, 2, 3, 4 is the correct answer. So yes, if you see here, in crop rotation, crops are changed from year to year according to a planned sequence. The crops are changed. Different crops are cultivated in different times. They are not using the same crop. They are not cultivating rice again and again and again. Right? They are changing the types of the crops which are cultivated in a particular land. And the sand fences, the simple and cheap method of inducing the accretion of sands in arid and sandy areas. So these sand fences are barriers made of small, evenly spaced wooden slates or fabric. Then terrace farming is the practice of cutting flat areas out of hilly or mountainous landscape in order to grow crops. And what is windbreak? Windbreak is also known as shelter belt. It's a planting usually made of one or more rows of trees or shrubs planted in a manner as to provide shelter from the wind and to protect the soil from erosion. So this is the picture of that wind barrier, sand barrier. This is the sand, and we have this barrier to stop the sand from taken away from the wind, and this is the wind barrier. The wind is coming from this direction, and we have trees grown here, and this is the crop which we are having. So this particular barrier, it is stopping the wind from soil erosion. So that's all for today's class. Let us see in the next class. Thank you, students.